Good morning. This is 6th grade in Gage, New York, Module 3, Lesson 18. Today we're going to be coming up with rules for how to calculate distance on a coordinate plane. You'll need the Lesson 18 classwork. We're going to start with the opening exercise. Four friends are touring on motorcycles. They come to an intersection of two roads. The road they are on continues straight, and the other is perpendicular to it. The sign at the intersection shows the distance to several towns. Draw a map or diagram of the roads and use it and the information on the sign to answer the following questions. Now, when we're reading that, one word really stuck out to me. The word perpendicular. It is a word that you should have heard before, but you may or may not remember the meaning of it. A lot of times it's taught with the word parallel. Parallel lines are a little more common. Push pause while you think about what are parallel lines. See if you can come up with some examples. See if that'll help you to refresh your memory on what perpendicular are. Push pause until you've had a second to think about it. Okay, as you may recall, parallel lines are two lines that stay the same distance apart forever. Because remember, lines continue on in both directions to infinity, so parallel lines stay the same distance apart. So they might be horizontal. These lines don't get any closer together, they don't get any further apart, and if they continued on forever, that would be the same. They can be vertical, they can be diagonal, they can be different lengths. They stay the same distance apart, they never get closer together, they never get further apart. So a non-example of that would be these lines. They're closer together here, they're further apart there, and if this line continued, it would run right into that one. So those are not parallel lines. All of these are examples of parallel lines. Now, perpendicular, the word that we need to define today, are not parallel. These are actually two lines that intersect at a 90-degree angle. So it might look like this. So here where they meet, there would be a 90-degree angle. On this side, that side, all four would be a 90-degree angle. It can be on an angle as long as that's a 90-degree angle. Now, a non-example would be these lines, where they intersect. This is an acute angle, these are obtuse angles, none of them would measure 90 degrees. So perpendicular are two lines that intersect at a 90-degree angle. So now, when you're looking at our coordinate plane, can you find two lines that intersect at a 90-degree angle? Can you find perpendicular lines? So now when we look at our axes, they do intersect here at the origin, and they intersect in a way that you could measure with a protractor that each side would measure 90 degrees. So our axes are perpendicular lines. So now we're going to use our coordinate plane like a map for the motorcyclist. So they're touring on motorcycles. They come to an intersection. So what on our coordinate plane would represent the intersection? So where they meet is the intersection. So the origin is the intersection. So this is where our motorcycles are. I'm going to label it M. That's where the motorcycles are. And as they're sitting there, they see this sign. Well, we need to determine which part of the axis are they on? Because the road that they're on continues straight, the other is perpendicular. So for the sake of this, I'm going to say that they're on the y-axis and they're traveling up this direction. So they're on the y-axis, they're driving up, they stop at the intersection, and here's the sign. It says Albertsville is 8 miles left. So if I were here and I wanted to go to Albertsville, I would need to go left 8 miles. So we need to figure out our scale for this map. So I need to know, how far am I going to go for 8 miles? Well, looking at the numbers here, I think I can go for a scale of 1 to 1. So I'm going to count by ones on both my x-axis and my y-axis. And 1 unit will equal 1 mile. So Albertsville is 8 miles to the left. So 1, 2, 4, 5, 6, 7, 8. Now these numbers are negative because my origin is 0 on the y-axis. Numbers on the left of 0 are negative. So this is Albertsville. Okay, now I go back to the intersection. It says 3 miles straight ahead is Blossville. My y scale is 1, and 1 unit is 1 mile, so I'm going to go 3 units. 1, 2, 3. Here's Blossville. Okay, Cheyenne is 12 miles straight ahead, so back to the origin, 12 miles from here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here we have Cheyenne. And then lastly, Dewey Falls is 6 miles to the right of the intersection. So here I'm at the intersection, 6 miles right, 1, 2, 3, 4, 5, 6. So here we have Dewey Falls. Okay, so now that we've turned our coordinate plane into a map, we are going to use this to answer the following questions. What is the distance between Albertsville and Dewey Falls? Okay, so we've got a couple of strategies here. The first one we can count on. So if I start at Albertsville, and I know 1 unit is 1 mile, so that would be. Now, boys and girls, a lot of students make mistakes here. If I am starting here, I can't say 1 there. I haven't crossed 1 mile yet. So every space that we cross represents 1 mile. I haven't crossed any spaces yet. So this is, we're not counting there. Now, I've crossed 1 mile, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So from Albertsville to Dewey Falls is 14 miles. Okay, what is the distance between Blossville and Cheyenne? Okay, so here's Blossville, there's Cheyenne. Again, I'm not going to start counting here. I have to cross a mile first. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So from Blossville to Cheyenne is 9 miles. On the coordinate plane, what represents the intersection of the 2 roads? We've already talked about this, so make sure you spell origin correctly. All right, let's turn the page. Here they have given us 2 points. The points are -4, 0, and 5, 0. What do these 2 ordered pairs have in common? So looking at their digits, looking at the coordinates, what do they have in common? What's the same for both? Okay, well, the y-coordinate of both ordered pairs is 0. So what does that mean about their location on the coordinate plane? Well, if I go -4, 0, that puts me here. And if I go 5, 0, that puts me here. So if their y-coordinate is 0, that means they're located on the x-axis. When their y coordinates are 0, that means they're not moving up or down. So they are on the y-axis. How can we find the distance between the two numbers on the number line? Well, we've already talked about the strategy of counting the units. Let's see if there's another way that we could do that. So push pause until you think of maybe an equation that we could write to find the distance from this point to that point. All right, as you hopefully were thinking about, we know that this is 4 units to 0. And then we know this is 5 units. So we could add 4 plus 5 to get 9 units. The only problem with that is this is a -4. So we need to think of a way that we can look at the ordered pairs and write an equation to find the distance. So think about what that connection would be. How could we get this equation from these numbers? Let's count to make sure that it's 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And it is. So thinking about how to connect the numbers from the ordered pair to our equation, we'll move on to the next example. So for this one, they have given us the units 0, -6, the coordinates actually, and 0, -11. Okay, what do these ordered pairs have in common? And what does that mean about the location on the coordinate plane? So looking at the x and y coordinates, we can see that this time the x coordinates are 0. So now, if the x coordinates are 0, that would be 0, -6. 1, 2, 3, 4, 5, 6. And 0, -11. There's -6, 7, 8, 9, 10, 11. Okay, so here's our 2 points now. So when our x coordinates are 0, that means it's on the y-axis because we're not moving left or right. Okay, so now we can count 1, 2, 3, 4, 5. So it's 5 units from this point to that point. What equation could we write that would give us 5 points? Push pause until you have been able to come up with something. Hopefully you were able to come up with 11 minus 6 equals 5 units. But that still doesn't give us a connection because this is -11 and this is -6. And on this one, we had to subtract to get the answer, but this time we added to get the answer. So now we need to think about what could give us these numbers. How could we get these numbers from our ordered pairs? And what is the rule? When do we add and when do we subtract? So you need to be thinking about what connections can we make, what rule can we come up with that would always work. So push pause until you were able to come up with some. Before today, we have talked about distance, not on a coordinate plane, but on a number line. And we actually have a vocabulary word that tells us the distance from 0. So when we're trying to figure out the distance from 0, what is that called? Absolute value tells us the distance from 0. And absolute value is always positive because you can't have a negative distance. So when we are talking about distance between points on a coordinate plane, it would make sense for us to use absolute value. because that's one way that we can find distance